All right. Hello, everyone. Thank you all so much for joining. I hope you guys had a great long weekend. I hope that was really fun for you guys. I love the long weekend because it is like the perfect break at the beginning of the year. So I'm grateful for a good long break. Okay, anyways, our icebreaker for today is what is your favorite book or book series? I know last week we did favorite movie. So this time we'll do book or book series. Yeah. Oh, okay. Hi, Amari. I didn't see your message earlier, but yes. Yeah, okay. Arjun says Wings of Fire. Adichie says Percy. Oh wait, I should write these down. I'm trying to like get into the habit of like writing down your answers so that way I can remember these things better. Um, Normally I don't, but then I realized like if I'm reading these, I might as well write them down. Okay, lots of people are saying Percy Jackson. Wow, I should not be surprised. Aditya and Rohan say Percy Jackson. Amari says if I'm asking about series, Dogman or Wimpy Kid. Yep. And if it's a book, Outsiders. Okay. So fun fact, Outsiders is typically seventh grade, from what I remember. That's my COVID year. Seventh grade was like my full virtual year. So we did not read Outsiders. We read like something else. I don't know. It was like it was still a decent book, but like not like I don't know. I don't think it was Outsiders level. My sister read Outsiders and liked it a lot. So. I know that. Front desk. Oh, this is one that I've not heard of. What's it about? Is this like a fiction thing? This is what a DT says, by the way. Okay. Some hit says Harry Potter. Yeah, not a. Yeah, I'm like curious to see like how many Percy Jackson versus like Harry Potter fans we have. I don't know. Maybe this is like a poll to consider. Okay, Hunger Games. Yeah, the Hunger Games are pretty well written too. Um, Actually, I don't know. I read an interview like about like how Susan Collins got like the idea for the Hunger Games. Is I don't know. She was like at some kind of game show or something, and she was like, "What if this happened?" So it was like a really crazy kind of premise. But yes. Okay. Let's see what else. Harry Potter from Jason. Awesome. Viva, he says, series of unfortunate events. Yeah, that one's good. I think I try to like get into the show that they made and I don't know, I guess like the gray vibe. Honestly, that's the best way to say it. The gray vibe just did not like hit with me, so that's like one that I never really got into. um I'm a really big reader. I love to read. I read a lot of fiction, but I'm trying to get into some more nonfiction too. So maybe some of these books I will look at. Actually, I have a confession. I've never read Percy Jackson before. I feel like it's always been on my reading list, and then like at some point I felt like I just got too old to read it, and so I have never actually read Percy Jackson. Copy says Once Upon a Broken Heart by Stephanie Garber or Harry Potter. Yeah, yeah, yeah. I think I have like a sequel to this one, the one by Stephanie Garber. I don't know. It's like somewhere on my shelf. Akshin says Keeper of the Lost Cities. I love Keeper of the Lost Cities. And my question is the author still like writing books? Because I was literally reading this during COVID time, and I know the books were out before that. The books were out like when I was in like maybe fourth grade or something. And I like last I remember, I last finished one of her books in like ninth grade. And to my knowledge, I think the series is still going on, which is like totally crazy. Honestly, she could have ended the series like 4 books ago, but it's okay. I think it's actually like pretty well written until like she draws it out at the end. Like I think the end is very, very bad. But like the plot itself is good. I think the premise is good. Hi Vivek. It is so nice to see you. Wow, you guys are giving me more answers than I could keep up with. I'm so sorry. Let's see what else we have. Um, okay. Some hit says Harry Potter, Hunger Games as series or one as a book. Okay. Cool, cool, cool. Mina says Harry Potter. Awesome. Some hit says I despise Percy Jackson, not a fan of mythology. Okay, I feel like that's kind of valid. Yeah. Mina says Wings of Fire. Cyprine says Harry Potter and Secrets of Nicholas Flamel. Ooh, this is one I've not heard of at all. Secrets of Nicholas Flamel. Awesome. Okay. Dork Diaries. Yeah, that one's pretty popular. Oh no, what did I do? Oops, I accidentally switched modes. Okay, Dark Diaries, cool. Let's see. That's from Aradia. Rohan says, "Me too. I love to read." Yeah, that's awesome. Mina says Warriors. Wait, is this like the cat thingy? Or am I thinking of a different series? A tool says Harry Potter. By that he says, I feel like I'm the odd one out. Yeah. It's okay. I also haven't read Percy Jackson, so you're definitely not the only one. Hitosh says, I don't like to read unless I have a good book, and I never have good books. Okay, well, now you have plenty of good books on your screen. Pick a good series. I think it's so important that you guys read like at a young age because that like helps so much in high school. Like I promise you, being a good reader like makes your life 10 times easier. So like I would say get into the habit of like reading. It doesn't even have to be like nonfiction. Like literally just reading fiction is good. Like it helps a lot. I read a lot and that I feel like has helped me. So I would say the same. You guys do some reading. Okay. Let's see. Cyprini says, I have no idea what Percy Jackson is. I think some people will be very offended, but it is like basically this like it's like the mythology version of Harry Potter, but also like way longer than Harry Potter. Let's see. Oh, Nahal says One Piece. Okay, I've definitely heard of One Piece. One Piece. I thought it was a show though. I don't know. Oh, and Vika says Restart. Actually, I bought that from the book fair. I still have a copy, but it's pretty good. I think it's really good. I love Gordon Corman. He's like a great author. Um, oh, you guys are reading Restart in school? Okay, that's so interesting. We did not read Restart in school. We read something else. Cool. Oh, Big Nate. Yeah. Did they make a movie out of that? I can't remember. Maybe they did. OUABH from Kavya. Okay, I have no idea what that is, but that's interesting. Advitya says selection. Yeah, that's good. Cats. Okay. Yes. Books by Alan Gratz. Ah, Alan Gratz is a very good author. I'll just write the author name because there's so many great books by him. Oh yeah, Inheritance Games is good too. Okay, wait, there's so many good books. I wish I could go through all of these, but we're kind of like getting to 807. So I'm gonna go ahead. Oh, and Jason also says Harry Potter. Okay, cool. Yes, I'm gonna go ahead and I also have no more space to write anything. So let's go ahead and transition. This is really fun. I could talk about books for like this like for the entire class, like literally. So I'm gonna like limit myself. Let's go ahead and talk about our stuff for today. So today I think we're kind of hitting that transition point where we oh, actually, happy September. Now we're going to be hitting that transition point where we look into some pretty like complex stuff. I think this is like what a lot of people think of when they think of algebra. Also, this is like if you guys have attended our previous classes, this is like actually completely new material. So this has not been introduced in any of our old classes. So hopefully today will definitely be a little interesting. Today we're going to be talking about polynomials. We're going to start polynomials and kind of spend quite a few weeks on this polynomials and then dive into quadratics and cubics and things because that really is like a foundation of algebra, right? You don't really get far in algebra if you're not good with polynomials and things. So let's go ahead and talk about polynomials. I know last week we talked about like what a polynomial looks like the coefficient variables, exponents, all that kind of stuff, and like degrees and things. So let me just refresh that just in case, and then we'll go ahead and start talking about like some operations we can do with polynomials. Okay, so let's say I have the term um 5x cubed. Can you guys tell me what the coefficient is here? What is the coefficient? Okay, perfect. It's 5. I'm gonna abbreviate coefficient as coef, so like this. And this is a pretty common thing, so I would just know this. Okay. What's my variable? This one's pretty easy. Yeah, it's just X. It's the thing that like has the, oh wait, I guess I shouldn't give this away. I'll say my variable is var. And what is my exponent? There's only one answer to that. Yeah, it is 3. Okay, perfect. And I'll like, abbreviate this as exp. So the variable always is like raised to some kind of exponent. Sometimes you won't see it because the term will literally just be like 7y. But there's that implicit exponent of 1. So that's a thing. Okay, lovely. Great. So that's like what a term is in a polynomial. Remember, a term is a coefficient, variable, exponent combined. Okay, great. Cool. I see a lot of you guys are still kind of talking about like our icebreaker, which is really great. I'm glad you guys are finding things in common. But if we can like kind of transition to the math side of things, that would be great. So let's make sure we all have our attention on polynomials. Okay. So this is kind of like the big idea with terms and polynomials. So let's go ahead and kind of refresh like some of the polynomials we talked about. I'm gonna go ahead. and put one over here, just kind of an example that we can talk about. Okay, so this is another polynomial. This polynomial has four terms because we see four different things that have a coefficient, exponent, and variable. I feel like that's pretty self-explanatory, right? You see this is one term, second term, third term, fourth term, fifth term. Actually, this is five terms. Sorry, I misspoke. Notice that the negative one is actually a term. And that's a term where the coefficient is -1. The variable is x, but it's raised to the 0th power. And remember, anything raised to the 0th power is 1. That's why, like, this is still technically a term. We call this the constant term because there's really no variable attached to this. Constant. Okay, this variable is like implicit. We don't really care about it. Okay. Cool. So in polynomials, you don't only have to have one variable. You can have polynomials with multiple variables. That gets like super duper complex. Maybe we'll kind of talk about it. But you can definitely have like, for example, I could have like a y here. I could literally just have like a y instead of an x. Like that's totally possible. So that's like one thing to think about. And also another thing to think about is notice how all of the coefficients are whole numbers here. That's kind of important. We basically say that in a polynomial, you cannot have like fractions. We don't really deal with fractions here. We kind of deal with whole numbers instead. Okay, so those are the big things with polynomials. And then finally, let's talk about degrees. So once again, to refresh, a degree is, did I start recording? Yes, I did. Sorry. Okay, a degree of a polynomial is the highest exponent of any term in the polynomial. Okay, so in this case, this polynomial that I have here, what would the degree be? Yeah, it's gonna be 4. Thanks, Samhith. Yeah, and Cypreneith. Perfect. Yeah, it's just gonna be 4, which is absolutely right. So this is something that we call a quartic because the degree is 4. Um, let's say I didn't have any of this polynomial and I just had -1. What's the degree there? Yeah, it's 0, right? Because we said this has like the x term with the exponent is 0. So the degree is 0. This is literally just a constant. Yeah, that can, you will find that constants are so annoying in polynomials because they just make life 10 times harder. So I feel like everyone will end up being frustrated with constants at some point in time. But yeah, okay, cool, cool, cool. So degrees, you guys have got this. Why is it not 1? Oh, good question. Okay. The reason why it's not 1 is because if I had an exponent of 1, that would look like 5 times x, right? So if I just have the term -1, there's no x term. So to account for the no x term, we have x to the power of 0 instead. This is just 1, and it's the placeholder for like no x term. So yeah. If I did have like x to the power of 1, then this is equal to x, right? So x is still like relevant. Okay, good question though. That's actually a good question. Okay, cool, cool, cool. All right, so this is just a brief refresher of last week, which I think most of you guys like are doing really good with. So let's go ahead and talk about some operations. We'll start off easy and then get into like some really wacky territory. So let's first start off with adding polynomials. So I feel like we've kind of worked with this kind of thing before, just because like we've seen how to add something similar. Like we've definitely worked with polynomials a little bit, whether you guys realize it or not. So when you combine like terms, you're basically combining terms with the same variable and exponent. Okay. Remember how I said polynomials can have multiple variables? That's where the same variable thing comes into play. The other really big thing is exponents. So in this case up here, notice how I have x to the fourth and x cubed and x squared. I don't just combine them, right? And this goes back to basic exponent rules. The reason why we can't just combine them is because there's no property for me to add x to the fourth and x cubed. Like there's no such thing that allows me to do that. So that's why I have to keep my different exponents separate. I feel like that's like a pretty simple thing. You guys have definitely done this before. So if you're like, oh my gosh, I have no idea what's happening, just remember like this is all stuff like that has at least come up one way or another. Maybe we just didn't say the terminology, but the concepts are there. So let's go ahead and take a look at one pretty simple example. Go ahead and simplify the following expression for me, please. Okay, this expression. Go ahead and simplify that and let me know what you guys get in the chat. Okay, we got some speedy answers from Anvika, Bhavit, Arav, Tanish, and Avril, and Nahal, and sorry for Nathan Kavya, and oh my gosh, everyone, this is awesome. And I'm seeing basically a consensus that the simplification is going to be 4x squared minus 2x plus 8. And I wholeheartedly agree with that. So let's go ahead and look term by term. The first term in both ones that are the largest is going to be x squared. So let's go ahead and combine these x squared terms, right? 3x squared plus x squared is 4x squared. Then I have 2x minus 4x. So that comes out to be negative 2x. And then I have 5 plus 3, which comes out to be 8. Okay, so I think that's pretty simple. I don't think there's anything like groundbreaking here. So we'll do subtraction now, which is honestly just the same thing. You just have to be like careful about subtracting the negative. So let's just double check that we know how to do this, and then we'll go into some more difficult stuff. Oh no. Let me make that problem bigger. I know that's probably hard to read. Okay, there you go. Okay, I see an answer from a real. Let's see if everyone else agrees. Okay, I'm starting to see some similar answers. Okay, agree. Awesome. All right, so let's go ahead and break this down. Pretty simple. The big thing here is distribute the negative. The negative applies to all three of these terms, not just the first one, okay? So the first term, I'll have 5x squared minus 2x squared, which comes out to be 3x squared. Then I'll have 3x minus x, which is 2x. And then I'll have negative 2 minus 4, which is negative 6. Okay, this is like pretty simple stuff, so I'm not going to spend too much time on it. Let's go ahead. Well, actually, you know what? Just in case someone has questions, let me pause really quick because I know I keep saying it's simple, but sometimes like maybe something gets a little trippy. So if I need to pause, I'll pause. Okay. If you guys have questions, like feel free to DM and I'll walk through something again. Okay, no questions. Awesome. Okay, so let's take it up a notch. Let's look at multiplication. I feel like multiplication is also not bad. It can just get like kind of tedious. So it can be annoying, but I don't think it's hard. I think it's just like, ew, you have to do a lot of calculations. So in that sense, like you just have to be really careful and like attentive. So let's go ahead. We'll start easy, guys. I won't give you like trinomial multiplied by trinomial. We'll start easy. We'll start with something simple like this. Um, wait, that was like not it. That was kind of anticlimactic. Okay, here we go. Here's the climax. This is what we'll start with, which I think is not super scary. The big theme when you're multiplying polynomials is distributive property. If you want to think FOIL, that's totally great. FOIL is just for multiplying binomials, but the idea is the same, right? You're distributing the terms. So think distributive property. And wow, as I was saying all of this, you guys are already coming up with answers super quick, which is perfect. I told you it's not super scary. It's okay if it's hard to type. I know this is not like because now you have to click like Shift 6 every time. So it's okay. If someone puts in an answer and someone else says like agreed, like that's fine too. Okay. Anyways, let's go ahead and distribute, right? So you know what? Let me use some green. Okay. So the first term multiplied by this, so that's going to be 3x times 2x squared. Oh, okay. So these next couple of weeks are going to be a little hard in terms of writing just because we need to be careful with how we do our multiplication. So if I make a mistake because I accidentally write like an X instead of like a dot for my multiplication sign, please correct me. Like feel free to correct me. I try to like help it by writing my X's like this, but sometimes I forget and write my X's like this. So if you're ever confused about something I'm writing, please stop me. Okay, this is like our big thing, right? So I guess like maybe I should write this as a plus and then like write this as -1. That's probably better. Okay, cool. So all I did here was literally expand and multiply 3x by every single term. So starting off with 3x times 2x squared, this is going to be 6x cubed. And then I have 3x times 5x, which is 15x squared. See, I did that there. I wrote my less fancy x. And then at the end, we have 3x times -1. So that's going to be -3x. Okay, and that's our final answer. Yeah, perfect. Thanks, Bhavit and Hitharth, for kind of walking through step by step. And everyone else has also given us an answer. Awesome. Okay, so this is like not horrific. Maybe okay. Last week we did FOIL with like variables and stuff. Let's test it out once more, and then we'll do like our challenge problem for multiplying polynomials. Okay, there we go. Um, let's start with x. You know what? Let me just paste the problem. I don't want to confuse you guys by writing it. Okay, so like nothing super groundbreaking here. I think we've definitely done something similar before. Okay. Starting to see some answers come in, which is great. I'll write this in like purple. I think I haven't used that yet. So that's going to be x squared plus 8x plus 15 is what I'm seeing, which is absolutely right. Um, we're just going to FOIL this out. So I'm going to multiply my first terms together. That's going to be x squared. And then I'm going to multiply my outer terms. So x times 5 is 5x. And then I'm going to multiply my inner terms, which is 3 times x or 3x. And then my last terms, which are 3 times 15, or 3 times 5, which is 15. I got ahead of myself there. So this, you combine your 5x and 3x, those are like terms. And this comes out to be x squared plus 8x plus 15. Okay, awesome. All right. I feel like this is pretty good, you guys. If this was like weird for you, just think about when we did FOIL with like the two-digit numbers. That wasn't super bad, right? Except here, all we're doing is we're replacing one of the values with an x, with a variable. But the idea is entirely the same. Okay, awesome. Let's go ahead and do like one kind of like challenge problem and see how you guys do. This is one that I'm like totally making up on the spot. So like I don't know if you guys are gonna give me a right answer or not. So I will also solve this with you guys. I guess I can make this smaller too. Okay, let's make this smaller. All right, and okay, let's do 7x plus 1 times hmm 8x. No, I don't want to do 8. That's too big. Okay, 5x cubed plus. Wait, do I make this like even more brutal? No, it's okay. It's okay. I'll be nice. I'll be nice. Okay. Oh, never mind. I'm seeing head nods and things. Okay, I guess I'll make this like absolutely brutal. You guys have totally asked for this. Okay. All right, here we go. So this is going to be 7x squared plus 3x plus 2 times 5x cubed plus, um, I'll be nice with this coefficient. I'll write x squared plus, let's see, what else? Um, 4x, no, yeah, 4x plus 6. Okay, great. Let us do this extra hard challenge problem. It is okay, I think it just looks intimidating, but I'm gonna be completely honest with you guys. It's not hard. It's just a lot of like calculations. So just keep in mind what we've talked about with distributive property and just be super organized with how you're doing your calculations. But aside from that, this is not super duper hard. It's just a lot of calculations. Okay, I still do see a lot of side chatter going on. If that continues, like I'm gonna go ahead and like r restrict the chat so you guys can only communicate with me. I really don't want to do that because I like when you guys interact with each other, but let's make sure we're like holding off on the side chat. Yeah. Thank you guys. Okay, I think this one's gonna like take a minute because there's a lot going on, which is okay. Oh, just kidding. Okay, it seems like we've got an answer from Manit and from Anvika, which are gigantic. Okay, this is amazing. I'm gonna wait a little bit and see, not a little bit, but okay, Anvika needs to simplify. Awesome, awesome. Hitharth wrote it on paper. Okay, good. Yeah. All right, and Thunvi put in a similar answer. Cool. Okay. Yeah, I know this is like not the most exciting thing mathematically because it's a lot of dash. But I think it's important we cover this because if you can master this problem, like you're set for a lot of polynomial multiplications. Okay, yeah, it's okay if you always don't want to type it. I think we've got enough answers, so let's go ahead and start working through this together. All right, first term. Yeah, the answer is really long. I just had so many people like make it harder, so I was like, fine, I'll make it harder. So let's start with the 7x squared, right? I'm going to start with this term. I mean, first of all, because it's on the left and also because it's the smaller term, so I think it's easier to multiply. So let's go ahead and multiply 7x squared by all this jazz, right? So 7x squared times 5x cubed plus x squared plus 4x plus 6. Very simple distributive property, right? Like you guys know how to do this. You guys did something very similar already. So if I go ahead and expand this, I will get 35x to the power of 5 plus 7 x to the power of 4 plus 11x cubed plus 42x squared. Do we agree with this? Is this all good? Yes. Okay, awesome. So let's go to 3x now, which is our second term over here. Um, and this is gonna be times 5x cubed. Wait, you know what? I can literally copy paste. Wait, if I can figure out how to do this. Okay, yes. Copy, paste, and drag. Yay! Okay, I just saved us so much writing. Awesome. Okay, and this is gonna be equal to 3x times 5x cubed is 15x to the fourth, right? So I'm gonna put this under the x to the fourth term over here. And then I have 3x plus x squared is 3x cubed. And then I have 3x plus 4x is 12x squared. And then I have 3x plus 6, or 3x times 6 is going to be 18 times x. Okay. And then for my last term, I will have 2 times, wait, can I still like, oh, yes, this is amazing. Okay, 2 times 5x cubed plus x squared plus 4x plus 6. Okay. And this is going to be equal to 2 times 5x cubed is 10x cubed. So I'm going to write that under the 10x cubed thing right here. 2 times x squared is just 2x squared. 2 times 4x is 8x. And then 2 times 6 is just 12. I think part of this is like not super difficult because I didn't have any subtractions. So maybe next time I'll put some subtractions in like the homework or something. Because if it's addition, it's definitely super simple. But with some subtractions, you gotta be super careful with your signs. Okay. Um, cool. Okay, let's go ahead and add all of this. I try to do it in a way that like, oh, 728. Okay, wait, I don't know. Okay. Anyways, I try to do it in a way where it's like very intuitive to add. So like you can see that there's no other x to the 5 term. So 35 times x to the power of 5 is our first term. And then I have 7 plus 15, which is 22 x to the fourth. And then I have 11 plus 3 plus 10, which should be wait, I'm seeing some like disagreement. Oh, wait, you guys are so right. This is my bad. Haha. This is 28. Good catch. Yeah, so 7 times 4 is 28. I accidentally wrote 11 because I did 7 plus 4. Okay. Yeah, don't add your coefficients. Please multiply. And this is a good example of how like in all this arithmetic, like we get something wrong. Yeah, thank you to whoever caught that. That's absolutely right. Okay. Cool. And that's actually what we're about to handle next. So 28 plus 3 plus 10 is going to be 41. Did I add that right? Yes, I did. Okay, 41x cubed. And then we have 42 plus 12 plus 2. What is that going to come out to be? I don't trust myself with addition anymore, so now I'm going to ask you guys. 56. Okay, awesome sauce. That is absolutely correct. 56x squared. And then 18x plus 8x is 26x. And then you have 12 at the end. Okay, awesome. So I think this is what most of you guys were putting in the chat, which is good. I think in retrospect, like a lot of you guys are saying now, oh wow, this is not super hard. It was just very easy to make mistakes with the adding and the multiplication. So if you got like maybe one arithmetic error or something, like honestly, like applaud yourself. That's like still really good. Because the trickiest part in here is the arithmetic. I think the actual idea of like distribution is pretty easy. Yeah, it is tedious. It's like not annoying. It's very annoying and like not fun math. So I apologize, but I think it's important to talk about this. So Great. Thank you for bearing with me. I think we're gonna get into some more exciting stuff now. So you guys should be ready. Yes. Okay, awesome, awesome. Oh, Hitar says I don't like math at all. I'm kind of just good at it. Okay, hopefully by the end of this class you will love math, or at least like it a little bit. I hope I can do that for you because math is really cool. There's a lot of it. But it says math is amazing when it is easy. That's true, but it can also be exciting when it's like hard. Like you sit with a problem for some time and then you get like a solution. It's like, oh my gosh, like I'm a genius that I solved this hard problem. So yeah, I think it can be fun both ways. Okay, anyways, tangent. Let's go ahead and talk about some important polynomial products. Um, okay, let's see. Let's just do some square properties really quick. I think you guys are all familiar with this, so I just want to make sure. Uh, does everyone know what a plus b whole squared is? Yeah. Okay, can you guys let me know what a plus b whole squared is in the chat? Okay, a squared plus 2ab plus b squared. Absolutely correct. Great. I think you guys have all learned this before. If you don't know why this is true, that's okay. Just go ahead, rewatch the recording, and make sure you FOIL it out. Foiling it out is the answer. When in doubt, FOIL. I promise that will get you somewhere. All right, and a minus b whole squared, what is this going to be? Ooh, does anyone know what a minus b whole squared is? Oh, there we go. We're getting some answers. Okay, be careful with your signs, you guys. So it's going to be a squared minus 2ab plus b squared. I see a couple of you guys putting, oh, wait, I'm lagging so hard. What is happening? Okay, b squared. Okay, there we go. I see a couple of you guys put your minus sign in front of that b. Remember, if the term is getting squared, there is never a minus sign in front of it. Like never, ever, ever. Okay? Cool. Can't you turn the negative into... Wait, Bobbitt, what are you asking? I'm not sure I like fully understand. Oh, do you mean like okay, do you mean like do a plus yeah, yeah, yeah. That works. Yeah. That's absolutely right too. Yeah, that works. Cool. That's like a notation thing. Yes. Yes, Bobbitt, that's right. And actually that's where this comes from. So if you know a plus b whole squared, you can literally find out a minus b whole squared without having to do any of this. Like you just plug in a negative. But yeah, that's a good way. Yeah, it's because they're additive inverses. That's very good. Yeah. Good comment, Amari. Okay, cool. So this is like not super groundbreaking. I guess we'll do like x plus 4 whole squared really quick, just to make sure that everyone knows what this is. Okay. You guys all said yes, so we'll just go ahead and say this. Oh yeah. If you guys could put in x plus 4 whole squared, that would be great. I think I didn't make myself clear. Yeah, it's x squared plus 8x plus 16. That's absolutely right. Okay, awesome. And then difference of two squares is also pretty simple. Can someone tell me what the factorization of a squared minus b squared is? Oh, wait, I'm seeing some question marks and ha's. Okay, is this not a known thing yet? Oh, okay, okay. All right, let's pause. Okay, I for some reason it was my intuition that this is also like um explained. But that's okay. Let's go through this. I do see some answers, and I think it's from mostly people that have taken the class before. But let's go ahead and break this down. Okay. How do I want to do this? Oh, okay. Wait, I'm thinking. Hmm. Okay, you know what? Let's just do it the normal way. Okay. Um, Wait, I'm like really struggling to think about how to say this. Okay. Okay, you know what? Let's just do it like normally. Okay, so I will tell you guys what the factorization is. This is probably gonna be like one of the few times I do this, just because this is honestly the best way to say it. So the factorization for a squared minus b squared is a plus b times a minus b. So if you guys go ahead and expand this, we'll do this together. We have a times a is a squared, and then a times negative b is negative ab. And then we have b times a, which is plus ba. And then we have b times negative b, which is negative b squared. So if we go ahead and cancel these, we'll simplify, and this cancels out. So we're left with a squared minus b squared. Like I feel like I definitely like pulled this out from somewhere, which is true. This kind of just came out of thin air. So I'm gonna have you guys like trust me that this is indeed a factorization. Well, you can see that this is a factorization. If you're wondering like how someone figured this out, I need to look into that a little more because I like can't remember off the top of my head how this came to be. But yeah, this is like super, super important, really important factorization to know. So I would highly recommend this is something you remember and practice. If you guys weren't able to catch what I was saying beforehand, I would recommend you go back and rewatch the recording. And if you guys still have questions, email me then. Awesome. Okay, let's see. All right. For some reason, my chat was closed. Let's see. Let's see. Okay. It is the same equation. Yes. Dora says this is like when you find them in a binomial, something you use. Yeah, 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 that is correct. What does binomial mean? Okay, good question. Yeah, binomial is something with two terms. So two terms. If you talk about like a trinomial, that's three terms. And then you kind of just keep going. So a polynomial is multi-terms. Okay. Cool. Yeah. Okay, okay. I think this is like pretty new for most of you guys. So let's pause here really quick. Um, okay. Cool. All right, so big idea here. A squared minus b squared is equal to a plus b times a minus b. And we went ahead and showed why that is true by just doing some FOIL. So we get a squared minus ab plus ab minus b squared, and that comes out to be a squared minus b squared. Okay, awesome. Is everyone good with this? Is this okay? Yes. Okay. Awesome. Awesome. All right. Let's go ahead and talk about factoring. Okay. Let's see. How many of you guys have done a little bit of factoring before? Okay. Interesting. Hmm. Okay. Okay. This is good. This is kind of good. All right. I think we'll start off with like factoring polynomials, which can be a little easier than it can be easier than quadratics, or it can be like way harder than quadratics. And I think that can be like a pretty distinguishing factor. Uh, okay, awesome. I was just responding to a question really quick. Okay. Wait, what do I mean by factors? Oh, okay. It seems like some of us have some questions about this, which is interesting. Yes, this is all good stuff. Okay. So some of the classes like, yes, I'm a factoring pro. And some of us are like, okay, factors, but what? Yes. Okay. So we say factors in polynomials in the sense like okay, because polynomials have variables, like our factors aren't just numbers, right? Our factors also have variables. So the factor for a polynomial is the things that you have to multiply together to get the polynomial. So it's like basically factoring with numbers, except now you have variables instead, okay? So that's the big theme here. I see someone brought up Simon's favorite factoring trick. That is something we'll hopefully get to talk about in the future. Actually, today at my math team meeting, I like led a session about Simon's favorite factoring trick. So that's definitely like a high school topic. We did that in math team. Um, but yeah. Okay. Uh, cool. Yeah, you can factor polynomials. You can, and actually, you guys have already done factoring in reverse, right? Because if we look at x plus 4 squared, you got x squared plus 8x plus 16, right? So if someone asked you to factor x squared plus 8x plus 16, you would just say it's x plus 4 squared, right? Because remember, think about how we factor like a regular number. We think about the things we have to multiply to get that number, right? So if I take 42, for example, I know I have to multiply 2 times 3 times 7, and that gets me to 42. So 2, 3, 7, and all the combinations of that are my factors. Now, the same thing comes with polynomials, right? With x squared plus 8x plus 16, I have to multiply x plus 4 by x plus 4. So x plus 4 is my factor in this case. Does this idea kind of make sense? Like the fact that we can like actually factor polynomials and things with variables? Yeah. Okay, awesome, awesome. Cool. So we'll start off with some pretty simple factoring tricks, but like Factoring, there's a lot of stuff to learn there. So this will kind of go on for a little bit. And then we'll kind of narrow it down and look at like quadratics instead. So this is kind of like general factoring for polynomials. Let's take a look. Okay. The first method is kind of just factoring out the greatest common factor. So this first example is going to be super easy. Go ahead and factor this expression for me. Oh no. Okay. Some of us say that this is hard, which is true. This is totally hard. You don't really get introduced to polynomials until like eighth or ninth grade, I think. Uh, okay. Sorry. There's like a lot of stuff going on in the comments, and I am very overstimulated. So super quick. Let's go ahead and factor this. Yeah, if you guys need me to slow down, let me know. I realize now how fast I've been talking, so I will try to like cool it down a little bit. Let's see what else. Okay. Hithart says the screen zooming out is so cool just sitting there in the corner. Wait, I don't know. I don't know what screen zooming thing I did. Okay, anyways. Uh cool. We've got some answers. I just didn't understand what you meant by factor. Okay, awesome. Yeah, so this is technically factoring. Like the answers you guys are putting in chat, that's all factoring. So let's talk about this, right? This is I think when I say factoring, some people get like super intimidated, like, oh my God, factoring is horrific. But this is technically factoring too, so not super bad. All right, we factor out the greatest common factor, right? So we see that both coefficients are divisible by 3, so that is one thing I can factor out. But also the x squared terms are common in both, so I can factor out x squared, and then I'm left with 2x plus 3. All right, how do we feel about this? Is this good? Yes. Okay, amazing. Yeah, not super difficult. We just find the greatest common factor and just pull it out like that. Okay, awesome. So let's go ahead and look at factoring trinomials, which is kind of where, like, I guess this is where we talk about quadratics a little, but I'm not going to spend too much time because I think there's more, I want to spend more time later. So we'll just do one really quick example. Can you guys go ahead and factor x squared plus 7x plus 12? Yeah, and because like here's where the wonky stuff happens, and that is absolutely true. There's definitely wonky stuff here. If this gets to be like super difficult and I think we're not grasping it, we'll go ahead and skip it for now and return to quadratics in a couple weeks. Yeah, okay. I think there's like a good like sense of confusion, which is totally okay. Yeah, that's okay. Okay, you know what? Let's skip this. I see some people say quadratic formula, and I see some people giving some answers, which is good. But I think this is kind of out of our league for now, which is okay. We'll build up to it. We'll come into it later. Yeah, so I see a couple people saying quadratic formula. The nice thing is that you can actually factor this without quadratic formula. Like you can do it pretty intuitively. I also see a lot of people saying x times 7 plus x plus 12. I do want to say that is not correct. I don't want you guys to leave thinking that is correct because it is definitely not a correct factoring. When we factor, we should have no like constant terms like added, right? So when we factor, you should just have a bunch of things multiplied together. In this case, we have some addition happening like outside of our parentheses. So this is not an appropriate factoring. Now, I don't want to give the factoring away yet. But this is like not allowed. And that's what I mean, like constants get like super annoying, right? Because if this constant wasn't there and we just had like x squared plus 7x, you could pretty easily factor this as x times x plus 7, right? This is just pulling out the greatest common factor. But because we have this constant term, we need to account for that too. So that's where this gets kind of annoying. That's where like students are like, man, I hate this. So we will learn how to solve these kinds of things, but I think for now, let's hold off so we can spend like a good class kind of discussing quadratic factorings because there's a lot to talk about there. Okay. Bobbitt says so you can take factor of only parts of an expression instead of all. Um, I think it's kind of the opposite. When you factor, you have to factor the entire thing. So you can't just factor x squared plus 7x and then tack on a 12. You have to factor out like all of the terms. So that way when you multiply two things together, you get x squared plus 7x plus 12. And I actually see some people are now putting in the correct answer. So I'm going to mark this wrong because I don't want you guys to leave thinking that's correct. Um, Yeah, so let's see, because now that people are putting in the actual thing, I'll show you why this is a correct factoring. So a lot of people are saying x plus 3 times x plus 4 is the factoring, which is absolutely correct. So the reason why this is because notice how there's no term being like added towards the end, right? Like your terms are all binomials multiplied together. Does that make sense? We're not like adding a 12 at the end because if we go ahead and expand this, we get x squared plus 4x plus 3x plus 12. So this becomes x squared plus 7x plus 12, which is exactly equal to the expression we started with. So notice how that 12 is like built into this, which is what we want, right? So let's take it back to numbers. Maybe that's a better analogy. If I do 42, you guys would think I'm crazy for saying a factoring of 42 is 5 or 6 times 5 plus 12. You guys would think I'm crazy for saying this because that's not a factoring, right? That's not how we factor numbers. We would say that 42 is instead equal to 6 times 7. Well, it's the same thing with like polynomials. We can't just add a constant or like a term at the end. Instead, all of our terms have to be multiplied. I have to have only multiplication of my terms. Okay, so that's like the really big theme with factoring. Does that idea kind of make sense? Like why the x times x plus 7 plus 12 thing was not a factoring? Okay, I do see some questions, so let me just go back and double check. Um, Okay. Yeah. For those of you guys who are like, oh my gosh, what are these people putting in with like square roots and crazy fractions and stuff? Don't worry about that. We will talk about that later. Okay. Awesome. Awesome. Okay, Bobbit says I left the 12. But if you look closely, you'll see that when we multiply this out, the 12 is actually like accounted for, right? Because you get the 3 times 4 term. That's the 12. So that's where this 12 is. So that term is actually accounted for in our multiplication. It's not something we add on at the end. Okay, cool. Um, oh, I didn't even think about the 6, 7. That was like unintentional. My bad, you guys. I think I did the same thing last time. Okay, cool. Okay, one more before I switch. Yeah. If this is still like wonky for you guys, that's okay. We'll definitely come back to this and like review this when we do quadratics. So don't worry if this is still like a little uncomfortable. All right, so let's take a look. We have x squared plus, let's see, what do I want to do? I guess we'll do a negative thing now. We'll do some minus signs. Um, minus x plus 30. Go ahead and factor this for me, please. Yes, there is no 6, 7 in here, you guys. I promise you that. Okay, Bobbit says x minus 1 times x minus 30. Bobbit, double check what you get for that middle term. I think that's going to be a little different from what we have on the screen. Okay, I see a couple people now saying x minus 6 times x plus 5, which I think I agree with. Yes, that is something I will agree with. So x minus 6 times x plus 5, right? So this is something we're going to go ahead and factor out. If we multiply this, we get x squared plus 5x minus 6x. Wait, I think I did this wrong. Wait, yeah. Okay, hold on, hold on. I think you guys like read my mind and then I just like wrote something completely wrong. Okay, yeah. I don't think you could factor whatever I wrote before. Okay, this is what I meant to write, you guys. I'm so sorry. I like totally confused everyone. Okay, let's backtrack. So the original one that I wanted you guys to factor is x squared minus x minus 30. I think you guys like knew what I was trying to go for and you gave the correct factoring. But for those of you guys that were like, okay, that was not factorable. Yeah, you were right. This one is a factorable expression. Okay, and the factorization is this right here. So if you go ahead and Expand this out, you'll get x squared plus 5x minus 6x minus 30, and that simplifies to x squared minus x minus 30. Okay, awesome. I think I confused some people. So let's go back and clear this up. Okay, some people are like, this is hard. Yeah, this is hard. This is hard. I'm not gonna deny it, you guys. This is stuff that like high schoolers kind of struggle with too. So it's okay if this is like tricky. Please, 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 please stop me and ask questions if you need to. And remember, this is not the first time you guys are gonna be seeing this, okay? We'll definitely keep doing this over and over, because I want you guys to get like repeated exposure and be like good with this. Because this is like a good chunk of high school stuff. So like it's okay if this is like difficult, okay? Um, cool. Okay, yeah, so Bobbitt was like, what do you mean I can't factor the plus 30? You'll notice that there is actually no such factoring with real numbers for x squared minus x plus 30. That's something we'll show later on. For now, take my word for it. Yeah, okay. Um, Cool. Yeah, so I see a couple of you guys mentioning the quadratic formula. For something like this, I honestly wouldn't use quadratic formula. I think it's easier to identify the roots themselves, the factors themselves, than use quadratic formula. We'll talk about that when we get to quadratics in particular, but for now, let's hold off. Okay, cool. Yeah, you guys are smarter than some high schoolers. That's awesome. Good for you guys. Awesome, awesome. Okay, cool. So we'll give some more problems. I don't know if we'll do a lot of like like quadratic factoring problems in the homework because I want to wait off on that. This is kind of like a preview of what we're gonna do. But the big thing is like this greatest common factor stuff, which is like super easy for you guys. Good job. Okay. Um, let's do some factoring by grouping. Okay. Um, Yeah. Okay, we'll do factoring by grouping, and then if we have time, we'll go back to the quadratic stuff. Okay, cool. So grouping terms is going to be like probably your best technique for factoring polynomials. But it only works in like specific cases, right? Like you have to be very careful about like the terms you group together because sometimes you could like group incorrectly and like then your things don't work. So that's going to be a problem, right? Well, it's okay. Let's go ahead and take a look at this example and see if we can factor from here. Now, one thing you'll notice about factoring is you have to consider lots of different approaches to factor something. Even now, like could like with all the math that I have done, like there are sometimes things that like are factorable, but I don't know how to factor. So I mean that in the sense like there's so many different approaches you can take to factoring, and we're only covering like the tip of the iceberg. I don't even know all the ways to factor things, so like there's definitely a lot to learn here. Um, and I think like that's part of what makes factoring hard because there's just so many different approaches. So this is like another common one for polynomials. Quadratics have a bunch. If you start looking at like cubics and quartics and things like that, there's some interesting things there. So there's definitely like lots of crazy ways to factor. Okay, enough of my talking. Let's go ahead and take a look at this question. Oh, SumHip gives an answer of x plus 2 times x squared plus 3, and he doubts himself, but SumHip, you are absolutely right. That is absolutely a correct answer. Vishit, I think you're correct. I think maybe you had a typo though, with that x squared plus 2 term. I think you just like hit a wrong key. Um, Okay, Kavya says x plus 2 times x squared plus 3. That's absolutely correct. Manit says x squared. Okay, yeah, yeah, yeah. And I'm seeing a lot of agreement. Okay, awesome. Cool. Okay, this is great, you guys. Awesome, awesome. So let's take a look. When I say factoring by grouping, I mean find groups that have things that can be factored, right? So the idea is like you try to find groups that have like common factors, okay? So one thing that like really jumps out to me is x squared plus 2x. I can very easily factor out an x squared term, right? So if I factor out x squared, or you know what? Let's write this as like x cubed plus 2x squared plus 3x plus 6, right? So now I'm going to factor out common factors. So for x cubed plus 2x squared, there is a common factor of x squared. So if I factor that out, I get x plus 2. Does this sound okay? Yes. Okay, awesome. And then in this term over here, I see that there is a 3 term common to both. So if I factor out the 3, I get x plus 2. Is that okay? Yeah. Okay, lovely. Now, this is the step that's like really important, right? So this is the step where you determine whether or not you can actually factor this thing. Because if these like parentheses terms are different, then you cannot go ahead and combine these terms, right? Because they're not like terms. But because I have x plus 2 and x plus 2, this is like reverse distributive property, right? So I go back and I get x squared plus 3 times x plus 2, right? Because I can pull out an x squared and a 3, combine those together, and then I just multiply all of that by x plus 2. And really notice how all we did was kind of just do distributive property backwards, right? Like if you read this from bottom up, it's literally distributive property. Isn't that like super neat? Because if you see here, I go ahead and I do x squared times x plus 2 plus 3 times x plus 2. And then I go ahead and expand each thing. That's shown here. And then I go ahead and combine everything to get this thing at the top. Okay? And that's the like theme with factoring, right? Factoring is all about like um, it's always like going to be reverse multiplication. You can think of factoring as like division almost, right? You're trying to find the things that like evenly divide something, evenly divide a polynomial. So that's why it's a lot of like reverse FOIL type thing. So if you ever want to check if your factoring is right, then you just FOIL out your factors. Okay. Um, yeah, this is definitely a little difficult. So let's go ahead and do one more example with like factoring by grouping, and then we'll kind of see where we are from there. Okay. Um, cool. This one is one I'll like make up from the top of my head. Um, let's do 3, or I guess I've done 3 a lot. Let's do 4x cubed plus, oh wait, I wrote x squared instead of x cubed. Man, sorry guys. Plus x squared. Um, and then we'll do plus, mm, okay, 12x plus 3. I think that should work. Okay. Yeah. Thanks, guys, for catching my writing mistakes. Okay. Let's go ahead and factor this. This will be our last thing for tonight, and then we'll go ahead and close. Okay. I see some have says x squared plus 3 and 4x plus 1. Let's see if anyone agrees with that. Okay, I'm seeing a little bit of agreement, which is good. Okay. Cool. Agreement. This is good. All right. I think because I kind of followed the format over here, it was pretty simple. But let's go ahead and break down how this is, okay? So first, I want to group my terms off. I'll do 4x cubed plus x squared, and then 12x plus 3, right? So if I go ahead and factor each term, in this first one, I have x squared in both terms. So if I pull out my x squared, I get 4x plus 1. And then in the second term, I see a 3 that's common to both, right? Both the 12 is divisible by 3, and this 3 is obviously divisible by 3. So if I pull out the 3, I get 12, or sorry, I get 4x plus 1. Okay? And notice how 4x plus 1 is common to both of these sums, right? It's in each term. So if I go ahead and factor out the 4x plus 1 almost, I get x squared plus 3. Isn't that kind of neat how we're able to reverse engineer our distributive property? Does that make sense, you guys? Okay, a real ask, isn't this kind of what we do in quadratics? Kind of, yeah. This is like one way to factor quadratics. I think it's easier to see it with cubics because there's an even number of terms, but you can definitely do this for quadratics. Absolutely. Good observation, Avril. Okay, this makes sense. Awesome. And now that it is 9 o'clock, let's go ahead and end for today. Thank you guys so much for attending. I hope you guys had fun. Hopefully, you learned something new. I think these next few weeks are going to be super interesting because we're going to talk about some really cool stuff with quadratics, and like polynomial division and all this jazz. So, lots of fun stuff. But yeah, thank you guys so much for joining me. Have a great rest of your week, and I will see you all next week. All right, awesome. Thank you guys so much. See you. If you have a question, feel free to stick around. Thank you guys. Have a great night, Tanish. Thank you. Awesome. Nahal, I know you were asking earlier about like repeating what I had said. If you want to go back and like rewatch the recording, like where you missed, I think that'll be a little more helpful. I didn't want to like kind of like backtrack since like we had a pace going. But yeah, I'm sorry I wasn't able to like reply fully to your question before. Yeah. If you want to go ahead, rewatch that recording and you're confused about something, go ahead and shoot me a question. Okay, awesome. Thank you guys so much. Does anyone have any questions? What is the next session? Honestly, I have no idea. I will have to decide. I will have to pick something based on what we've done. Maybe we'll do more polynomials based on how everyone does the homework, or maybe we'll go ahead and jump into quadratics, if that's the move. But we'll see. Yeah, bye, Amari. Thanks for joining. Awesome. Okay, thanks, Nahal. See you. Yeah. Bye, Tanvi. Awesome, awesome. Aditya and Vaibehi, did you guys have any questions? Let me know in the chat. I don't think you guys can unmute. Okay. All right. I don't hear any questions. Aditya, any questions? Okay, no. I'm gonna go ahead and close the Zoom meeting. All right. Bye, everyone.